In this video, we'll explore polyhedron and other solid shapes. Now, a polyhedron is a three-dimensional closed shape whose outer surface is made up of polygons. So, some of the key terms we talk about are the faces, the edges, and the vertices. The faces are those actual surfaces, and it's made up of polygons, so straight edge shapes. Our edges are where two of those polygons come together, so it's going to be forming a segment, just making up that edge. And the vertices are points, where multiple sides are coming together. So if I look, I have a polyhedron here because every side is made up of a polygon, straight edge surfaces. So I can even count the parts. I can see I have 6 faces: the front, the back, the top, the bottom, the left, the right. I can see that I have 12 edges, so I can count the segments. 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. And I can even count those vertices, the red points. 1, 2, 3, 4, 5, 6, 7, 8. Again, this is a triangle it's another polyhedron made up of triangles, and I can count those edges and faces. However, this is a cylinder, and a cylinder is not a polyhedron because it has a curved surface. Anything that's curved is not a polyhedron. It's just a three-dimensional solid. So one of the first ones we'll talk about are called prisms. And a polyhedron that has a base similar and parallel to one another is considered a prism. And when we talk about a base, it's the idea that I have this two-dimensional shape, and I'm going to extend it out to make it become three-dimensional. So it's got the sides extended to another one of its identity or similar shapes at the top. Now, it doesn't always have to be top to bottom. It could be left to right, could be turned sideways. It's just understanding what is the shape that's been extended. So if I look here, I would consider this a rectangular prism because I'm taking a rectangle and extended it to another rectangle. If I look here, the shape that's being extended out is that triangle. So this would be a triangular prism. And here if I look, I've got the pentagon that's being extended upward. That's considered a pentagonal prism. Now, cylinders are similar, but they are solid shapes who have circles as those bases. So when I look, it's like I've taken my circle and I've extended it up and given it some height. And I can have them turned left, right, they can be skewed, they don't have to be directly above one another as long as the two bases are parallel to one another. Now, pyramids are a solid that has a polygon base, and then faces that meet up at an apex. And a cone is similar in that it has a curved shape that then tapers up to a specific point, not on the base. So here I have a triangular pyramid because my base is a triangle, and technically I could choose any of those four sides to make my base. Here I have a pentagonal pyramid because my base, you can see there, is a pentagon reaching up to that fifth side, that apex. And finally, I have a cone. I've got my curved surface tapering to that final point away from it. Now, there's another term we talk about called right and oblique solids. If I am a right prism, that means that all the faces are perpendicular to the bases. If I'm a right cone or pyramid, that means the apex is directly at the center of the base. If not, the shape is considered oblique. And it does change some of the properties about how we can think about how to simplify surface area and volume when we have these features. So again, if I'm thinking about being right, I want that 90-degree angle so that the bases are one directly above the other. This would be a right rectangular prism. This, on the other hand, would be an oblique cylinder because it's the cylinder, but it's been shifted. Here I have a right cone. That's my center point, the apex would be right above the center of my base, whereas this would be oblique, and that's a nonagon, so I would say that's an oblique nonagonal pyramid.